Morning, ladies and gentlemen. First of all, let me ask you a question. What do you think you can do in this rapidly developing world of Internet of Things with the power to light up a single LED light? And I think your answer may be diverse. But my answer is that you can drive a whole ZigBee network system. So let's come to our project. And we are from Beijing Jiaotong University, and our project is the intelligent navigation and tracking system based on ZigBee. And I am Zhang Linkang, who is the captain of this team. And our professor is Lu Yong, and these are my two partners, Yeman Zhang and Pengxu Chen. So today's presentation will be divided into two parts as a whole. The first part, I will introduce about the ZigBee network system, which serves as a cornerstone technology in this whole project. And in the second part, I will introduce about this whole project. So let's come to the first part, and there are three sections: a general introduction, and the location technology, and the Z-stack operation system. For general speaking, the ZigBee is a low-cost, low-power wireless mesh network standard based on IEEE standard 802.15.4. And there was a very important feature. ZigBee nodes can sleep most of the time, which is why it will save a lot of energy. And I will introduce why later. On the right side is the protocol picture, and on the left side is the circuit picture, and based on which we build up our own hardware ZigBee nodes. And for the location technology, there are two kinds of nodes. The one is the reference nodes, and another is blind nodes. And there is a very important concept: the received signal strength indicator value. So let's come to look at this picture. The green node is the blind node, and the gray nodes are the reference nodes. The green nodes will talk to all of the reference nodes and receive the RSSI value from all of them, and so that it will know where itself is. And for the Z-stack operation system, it is like most of the operation system. There is one part of the core code which will repeat one and one again to detect the command. And the most important feature is this function, the power conserve function. And I will talk about this. For all of the general operation system, one of the code will repeat one and one again to detect the command to come, and then to execute the command. But in our system, if this green arrow is the current time, and all the red arrows are the time where the command should be execute. And for the common operation system, this part of codes will repeat again and again in this period of time. Actually, that do nothing, and the power is wasted. But in our system, it can sleep in this period and do the command at this point. And again, most of the time, actually the nodes are sleeping. But when the command is come, it will execute it, and that's the very important feature why the power is largely reduced. So the important thing is that the performance is improved in our project, and this is a very actually interesting application in this whole project. And then let's come to the second part of this presentation. The whole project has three functions as a whole: the navigation, tracking, and the controlling. Navigation means that the robot can lead you to the place you want to go. You just choose the destination, and it will calculate out the shortest path automatically. And the tracking, it will follow you behind you as you walk. And the control is that we build up a Bluetooth remote control system on our cell phone. And these are the other features of this project. And this can be applied to restaurants, supermarket, and factories. And actually, we have two versions of robot as a whole, and we bring the second version, 2.0 version, to Taipei this time. And then I will introduce you about it in 6 sections: the general introduction and the platform, and then the 4 functions, and in hardware and algorithm aspect. As a whole, it has 2 CPUs, different CPU has different functions. And this is the whole circuit. And it has a LCD screen on the robot so that you can control it using the button on the robot. And this is the platform of the robot. And for the most important, navigation, we use the 6 ZigBee nodes as a whole. 4 of them are the reference nodes, like this. It will be put into the 4 corners of the whole area it will move. And another 2 are the blind nodes, one connected to the computer, and so that the position of the robot can be revealed on the screen. And another blind node is on the robot, so that it itself can know where itself is, so that it can calculate out the path and to navigate for you. And this is the process we build up the whole ZigBee system to modify the Z-stack code and adding a location problem and using a serial port program to connect it to the MCU microcontrol unit on the robot and connect it to the computer on the other hand. And for the algorithm of navigation, it is a kind of shortest path algorithm, and this is a simple picture of it. And it is based on the Dijkstra algorithm to calculate out the shortest path, so the energy can be reduced in this aspect too. And this is tracking. We use two ultrasonic sensors to build up a tracking system. The 2 sensors are on the robot, so you just walk in front of it, and the robot is behind you, so that it can detect you using these 2 sensors, and it will follow you according to our algorithm. And for the 5th, we build a Bluetooth control using our cell phone. It is an Android application. It can use on your cell phone, and you can use it to control the robot at the same time. It is developed on the Eclipse platform using Java, and it is Android Bluetooth based. And the steps are pair the Bluetooth devices and send different codes, and then we can control it. And this is the 3rd function of the whole project. And then last but not least, it can avoid obstacles by itself. It is really user friendly, because when it encounters with the obstacles, it can avoid by itself using these sensors. And this is a really simple algorithm of that. And as a whole, our system using the cornerstone technology ZigBee to build a whole navigation and tracking system. And this is the whole picture of that. And thank you. And then let's come to the question and answer.
What's the accuracy of your navigation system? And the second, what's the size of the service area of the navigation? Thank you.
1.5 meter for the first question. And for the second question, it will the maximum distance between 2 nodes should be 64 meters. And so it is actually it can apply to the indoor areas, like in this hall, maybe, for example. Thank you.
What's the major innovation in your system?
I think there are 2 innovations on that. The first one is the application of ZigBee, because the ZigBee technology is not invented by us, but we use it in this application environment, so that it can serve you as a navigation and tracking function. And we modified the code of the original operation system of ZigBee, so that it can do better in this application environment. And for the second innovation point, I think is that this whole project is not only about ZigBee. It is a kind of service robot, because the robot is a mainstream in this age. So we put so many functions on it, so that it can be applied to different using environment, and it can be multifunctional. I think in restaurants, in maybe in factories and in airports. It can help people to navigate or carry the things for the people to the different places. I think this is another innovation point. Thank you.
For the commercial applications, usually a range detector will be very expensive. Taiwan Jiao Tong University have invention of the navigation wheelchair, where the radar detector is quite expensive. You say that you have that optical avoidance systems with the range detector. Is that your design or is a commercial available device?
The Zigbee system is our device. We
the
draw
range detector.
The range detector. You mean the ultrasonic sensor?
Right.
Yeah.
No, not ultrasonic. It's the other one. You show there's optical avoidance device.
This is a very simple infrared sensor. It is not designed by us. It is bought from the market. Yeah, thank you.
谢谢。
Thank you for your questions. Our project's name is the Intelligent Navigation and Tracking System, which is based on the Zigbee network. And this place is too small, so let's follow me and we go to the big ground. All right. And this whole project has 3 parts. The first part is these 6 Zigbee nodes like this. There are 4 on the 4 corners of this area, and one connected to the robot, and one connected to the computer. And the whole system has 3 functions. The first function is that it can navigate because it has a node on itself. So if it can know where itself is, and if you choose the destination on the screen, and it will bring you to the destination. And for the second function, it will follow you through these 2 sensors. It will sense the user so that it can follow you behind you. And for the third function, we build up an Android application which can control this robot's movement. And first, let's take a look at this screen. If we turn on the battery, you can see that it has 3 working modes: the navigation, the follow, which is tracking, and for the C is control. And you can choose it through these buttons. And if we choose navigation, it has 3 destinations: warehouse, factory, workshop. And their coordinators are written in this CPU, so that if you choose one, like this, it will demo the destination factory, and its X coordinator and Y coordinator will be displayed on its screen, so that itself can know where itself is, and then it will calculate out the shortest path to the destination and then bring you to it. And because this place is too small and it is applied to a more larger house, so that we cannot demonstrate this function here. But we can demonstrate the other ones, like Bluetooth control. Bluetooth control. And because this node is on, so that look at this screen, and these 4 nodes are actually these 4 ones on the 4 corners of this whole area. And if it is applied in a factory, it will be put in the 4 corners of a whole factory. And then the place of the robot can be revealed on this screen. And if we choose the control mode, and I will be able to control its movement, and it will take a second. We can have a try on it.
How you speed?
These are 4 directions of it. And in the middle one is start. And for the most important thing, because the ZigBee network we designed by ourselves, it is very it saves a lot of energy because when it is not, when it receives no command, it is in a sleeping mode. And look at this one. We just use 2 AA batteries in it, and the battery we use in these 6 nodes, we have used it for 1 year, and it can still be used. The power consumed
For the navigation mode,
yeah.
while you are detect the power signal.
Yeah.
Here, we are so many people here.
Yeah.
So many artifacts.
Yeah.
So that will make it difficult to demo the function of it.
Yeah.
That's what I think.
Yeah.
So if you using this kind of, you need very open and very clear.
What do you?
Another, the temperature, humidity will affect the major issue. Yes, on the power